This video is for homework and Mastery 3.3, sections 10.6 and 18.1 in your textbook. Looking at functions. What we're going to do here is, first of all, understand what a relationship is. A relation is any set of ordered pairs. If you notice, an ordered pair, for example, 0, 2, and -3, 4, those are ordered pairs. The relation y depends on the value we put in for x for this equation. This is a relation because we relate our y to our x value. We have our independent variable, our x, and then we have our dependent variable, y. Our dependent variable is y because it depends on the value that we put in for x. When we look at these, where we want to state the domain and the range of the relation, the domain consists of all the first coordinates in the ordered pair, or all the x values in the pairs. Our range consists of all the second coordinates in the ordered pairs, or the y values, our dependent variables. So for this example, our domain will consist of 3, 10, 11, 13, and 9. We usually put our domain in order from least to greatest, so I've got 3, 9, 10, 11, and 13. Our range would consist of our second coordinate in our ordered pairs, 5, 12, 8, 15, and 12. Again, we want to look at those. Notice I only put 12 one time because it repeats. I don't have to put the 12 in there multiple times. I just need to make sure that it is in there one time when we're talking about range. A function is a relation in which no two different ordered pairs have the same first coordinate, meaning our domain does not repeat. Remember, I said the domain was our x values and our range was our y values. So for an equation or a relation to be a function, which is a special kind of relation, the domain cannot repeat. This particular relation is a function because notice my domain does not repeat. My domain has -3, 0, and 3. It is not going to repeat. If we look at this example, 2, 5, we've got the points 2, 4, 5, 4, -3, 8, 2, 6, 1, -7. We want to state the range and the domain for these points, and then determine if the relation is a function or not. Well, our domain, remember, is the first coordinate in the ordered pairs, 2, 5, -3, 2, 1. And our range is the second coordinate, 4, 4, 8, 6, and -7, as I've shown here with the lines. So where I put them in our set notation, our domain is 2, 5, -3. I don't put the 2 again, and 1. My range is 4. I don't have to put the 4 again. 8, 6, and -7. Then I want to determine whether this relation is a function or not. Remember, in order for something to be a function, the domain cannot be repeated. Well, if you notice, I have a 2 here and a 2 here for my domain. Therefore, this is not a function because two different ordered pairs will have the same first coordinate. I also want to look at being able to graph equations, such as y is equal to x squared. This is not a linear equation. This will be what we call a parabola. But when we look at it, we want to create an xy table and be able to plot points. So we construct a table of values. I choose values for x, and I have chosen -2, -1, 0, 1, and 2, and I'll plug those in for my x and solve for my y. So I get -2 squared is 4. So I'll have a point at -2, 4. -1 squared is 1. So I'll have a point at -1, 1. And so forth. So I'll have the points -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Those will be my points that I will use to graph. After I get my table constructed, I'll plot my points just as I have here. I've plotted the points on the graph. -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Once I have plotted the points, I connect the points with a smooth curve. And I have now graphed my equation. Let's look at another one where I'm going to graph y is equal to x squared plus 3. I will do the equation in the exact same way where I'm graphing. I will first begin by constructing a table of values. And so I'm going to choose the same values of x, -2, -1, 0, 1, and 2. -2 squared will be 4. 4 plus 3 gives me 7. So I will have a point at -2, 7. -1 squared is 1, plus 3 will give me 4. So I'll have a point at -1, 4. 0 squared is 0, plus 3 is 3, and so forth. So I will have the points -2, 7, -1, 4, 0, 3, 1, 4, and 2, 7. I'll plot those points on my graph, as I have done here, and connect the points with a smooth curve. I have now graphed the equation y is equal to x squared plus 3. Let's look at one more where we have x is equal to y squared plus 2. Here, since I already have the equation solved for x, what I'm going to do is I'm going to choose values for my y and solve for x, because it's very easy to plug in points for y and solve. So I'll use the same points for y that I have been for x, -2, -1, 0, 1, and 2, and I'll solve for x. Notice I rewrote the y column out here. This way I can read off my points very easily again. -2 squared is 4, plus 2 is 6. So my x value is 6, for my y value being -2. So my point is 6, -2. -1 squared is 1, plus 2 is 3. So my x value is 3, so my point is 3, -1. And I do the same thing all the way down. And I have points at 6, -2, 3, -1, 2, 0, 3, 1, 6, 2. I will plot those points. Here is 6, -2, 3, -1, 2, 0, 3, 1, and 6, 2. I will connect the points with a smooth curve. Notice wherever I have x equals y squared, it points to the left or right. Whereas wherever I had y equals x squared, it would point up or down. This is called a hyperbola, where the others were called parabolas. To determine if a graph is a function or not, we want to look at what we call the vertical line test. If a vertical line can intersect the graph of a relation more than once, the relation is not a function. If no such line can be drawn, then the relation is a function. Which means if I draw a vertical line through my graph at any point and it only touches one time, I need to continue and look and see if that's true for the whole thing. But if I can draw my vertical line at any point of my graph and it touches more than once, 2, 3 times, it is not going to be a function. So let's look at some examples. I have A, which will be a parabola. I have B, which is a hyperbola, and C, which is a circle. If I look at A, I'm going to draw a vertical line, and wherever I do so, notice it only touches my graph at this point. So you would think that this would be a function. Well, if I move my vertical line to the left or to the right, it will still continue to only touch my graph at one point. So A will be a function. A parabola will be a function. Now if you look at part B, if I drew a vertical line here at the very end, it would only touch one time. But what if I draw my vertical line here? Notice it touches one time here and one time here. Therefore, this hyperbola is not a function. Looking at my circle, I could draw a vertical line at my very end point here or here, and it would only touch one time. But if I draw my vertical line anywhere else, such as here, notice it will touch my graph 2 times, making it not a function. The function is a very special type of graph, and therefore you have to be careful. X squares, x cubes, and those types will be functions. A straight line, unless it is a vertical line, will also be a function. Here we get into function notation, f of x. Don't panic, the f of x just means the same thing as y. I've literally replaced the y with f of x. This is function notation because it's going to tell me whatever is inside this parentheses, I'm going to replace every x inside my equation with that number. So if f of x is equal to 3x squared minus 4x plus 5, find each of the following. So if I look at f of negative 2, what this means is I want to replace all of my x's in my equation with a negative 2. It's important that you get used to rewriting and writing down every step of your problem. That way you're not missing anything and you can see what you're doing. For example, I have written f of negative 2 is equal to 3 times negative 2 squared minus 4 times negative 2 plus 5. Notice, in my original function, I have taken everywhere there's an x and placed a negative 2. Remember to go ahead and put what number you're replacing x with in parentheses. This will also help you. The negative 2 squared becomes 4, and then I can multiply 3 times 4 will give me 12. Negative 4 times negative 2 gives me 8 plus 5. 12 plus 8 is 20 plus 5 is 25. So f of negative 2 is 25. This actually gives me a point on a graph. What it does is says that where x is negative 2, y is 25. So my point would be negative 2, 25. Let's look at B, f of 4. That means I'm going to go back to my original equation and I'm going to replace the x's with 4, as I've done here. 3 times 4 squared minus 4 times 4 plus 5. 4 squared becomes 16, and then I can multiply. 3 times 16 is 48. Negative 4 times 4 is negative 16 plus 5. 48 minus 16 is 32 plus 5 is 37. So f of 4 equals 37. My coordinate for this point would be 4, 37. I do the same thing for f of 0. I'm going to substitute the 0 in for the x. And notice that whenever I do that, my 3 times 0 squared just becomes 0. My negative 4 times 0 becomes 0 plus 5. So 0 minus 0 is still 0 plus 5 gives me 5. So I will have a point at 0, 5. Evaluating expressions just means what we have been talking about. We're going to substitute the value inside the parentheses for whatever we're looking for. We're going to replace every x with that value. If h of x is equal to x squared minus 3x minus 5, find h of negative 2. This means the exact same thing. I'm going to replace the x with a negative 2. Notice I wrote down my original problem, and then right underneath it I'm writing h of negative 2. And I'm replacing my x's with negative 2. Again, I will caution you, make sure that you're placing whatever value of x inside parentheses, because it will change your answer if you do not. So negative 2 squared will become 4. Negative 3 times negative 2 is 6 minus 1. 4 plus 6 is 10 minus 1 is 9. So h of negative 2 is 9. Here we have, if t of x is equal to 6 over x minus 3, find t of 5 and t of x minus 5. Let's first look at t of 5. I'm going to replace my x with a 5, as I have done here. I need to simplify my denominator. 5 minus 3 is 2. 6 divided by 2 is 3. So t of 5 is 3. Now whenever I want to replace my x with x minus 5, I'm going to replace this entire x with this entire parentheses, which is what I've done here. I've taken the x and put x minus 5 in its place. So now I have 6 divided by the difference of x minus 5 minus 3. I'm going to simplify my negative 5 and my negative 3, which will give me 6 divided by x minus 8. At this point, I cannot simplify any more. There's nothing else I can do to the denominator. It's as simplified as it can be. And I can't do anything with the numerator. Since I have this minus sign in the denominator, I cannot simplify the 6 and 8. So my final answer, t of x minus 5, is equal to 6 divided by x minus 8. We do have to be careful when we're looking at these. Make sure that you're replacing all of your x's with your number, and make sure that you're paying attention to any positive or negative signs that might be in front of your x, anything like that. If you need any help, please let one of us know. We'll be glad to help you.